Assalamu alaikum, dear students. We have another lecture of chapter number 20, that is radioactivity. This is 20.6, okay? 20.6, natural radioactivity, or this is called the spontaneous disintegration. This is another name of radioactivity. Okay. Um, Look at the introduction. Radioactivities. Okay. Radio mean rays are emitting, activity mean process. Radio mean rays are emitting, activity mean process. The process in which the rays are emitting from a compound, from an element, that is called radioactivity. Remember, radioactivity was discovered by Henry Becquerel. Henry Becquerel, okay, in 1896, and he found this process accidentally. This was an accident. How it was an accident? Because Becquerel wrapped the uranium compound in a photographic plate. Photographic plate means a screen. Okay, so Becquerel wrapped a uranium compound in the photographic plate, and he placed it in a drawer. And after some time, he found that there are some images of the compound on the photographic plate. So he was very surprised. When he found a very strong image on the plate, he realized that the uranium compound was emitting from the form of radiation without having been exposed to the sunlight. Means the uranium compounds emitting radiation, and those radiations were falling on the photographic plate, and there are strong images, strong radiations on the images on the photographic plate. So he realized that there are some sort of radiations are emitting from the uranium nucleus without having been exposed to the sunlight. Means in the absence of sunlight, uranium were emitting energetic radiations. So that radiations is called the radioactivity. This process is called the radioactivity. So let's we have to we define radioactivity. So the process the process in which a heavy nucleus mean unstable nucleus, which has Z greater than 82, heavy nucleus emits radiation naturally is called radioactivity. When a heavy nucleus emits radiation naturally is called radioactivity. Okay, so suppose if we have a very large heavy nucleus which consists of very large number of protons and neutrons, means the nucleons. If we have a large number of nucleons, so this nucleus will emit radiations naturally, spontaneously. So this is called radioactivity. So if someone asks you why this nucleus is emitting radiations, so your answer should be is to this nucleus emits radiation is due to get stability, because this nucleus is very unstable. Heavy nuclei are very unstable. To gain stability, so the nucleus should release some sort of energy or radiation or particles. Okay, now delta n by delta t means the rate of decay is directly proportional to stability. Means if the decay rate is greater, stability will be achieved. Stability will be quickly achieved. So it means that decay rate is directly proportional to stability. So this process is to gain stability of heavy nucleus by the heavy nucleus. Okay, now I want to find which type of radiations will be emitted from this heavy nucleus. So suppose this is a heavy nucleus, Hn mean a heavy nucleus, and I place it in a container. This is actually a lead container. A lead container is a good shield for harmful radiations. Means a lead container is opaque for harmful radiations. Means uh, no radiation can pass through the lead container. Okay, so it is opaque for the energetic radiation. So it means if this heavy nucleus emits radiations, so these radiations cannot penetrate from the lead container. Okay, now we place an electric field, a positive plate and a negative plate, and we placed a screen. A screen mean a photographic plate. This is a photographic plate. Okay, we know that the direction of electric field is from positive to negative. So the radiations emitted from the nucleus will be go straight in this direction. So some radiations come and it will be get repelled by the positive plate and get attracted by the negative plate. So it will bend towards down. So these radiations are called alpha particles, and some radiations were attracted by the positive plate and will repelled by the negative plate. So these are called the beta radiations, and some radiation will some radiation were move straight and fall on the photographic plate. So these are called the gamma radiations. So there are three type of radiations emitted during the radioactive process: alpha, beta, and gamma. We know that alpha has doubly positive charge, beta has negatively charged, and gamma is neutral. Gamma is in energy. Okay. Now, first we are talking about the alpha emission. First we are talking about the alpha emission. What is meant by alpha emission? Alpha emission means the helium nucleus, means the two protons and the two neutrons combinedly called the alpha particle. Two protons and two neutrons combinedly called alpha particle. So the charge number of the alpha particle is 2, mass number is 4. Mass number is 4. So this is actually the helium nucleus, alpha particle. Okay. So it has a charge number 2 because there are 2 protons, and mass number is 4 because there are 4 nucleons. Okay. Suppose generally if we talk about the alpha particle, so look at the reaction. This is a nucleus A, X. This is nucleus X which has charge number Z. It's number A. It emit alpha particle, and so its charge number will be decreased by 2 and mass number will be decreased by 4. Means because 2 protons are emitted, so the charge number will decrease by 2 and mass number will decrease by 4. And some disintegration energy, Q is the disintegration energy, which is always positive as the process is spontaneous. This process is natural, so this Q is called disintegration energy, so this is always positive. Okay. So this nucleus is called the daughter nucleus, and this nucleus is called the parent nucleus. So the parent nucleus will be heavier and the daughter nucleus will be lighter, and we can say the daughter nucleus will be more stable than the parent nucleus. Okay. Let us take an example of uranium 238. Suppose we have uranium 238. This is uranium 238. It emits an alpha particle, so it will become thorium. Thorium has a mass of 90, has a charge of 90 and mass of 234. If it emit a helium nucleus, and Q is the disintegration. So look at here. If uranium emit alpha particle, so its charge number will be decreased by 2 and mass number will be decreased by 4. So the mass number becomes look at the mass number. It is 238 and it becomes 234. So the mass number is decreased by 4. Look at the example of radium. So radium has 88 charge number and 226 mass number. So if it emit a helium nucleus, means the alpha particle, so its nucleus will be Rn, radon 86 and its mass is 222. So look at the difference. So its charge number is decreased by 2 and the mass number is decreased by 4. So the mass number is decreased from 226 to 222. So decreased by 4. Okay, increase the disintegration energy. So it means whenever a nucleus lost an alpha particle, emit an alpha particle, so it will gain more stability as compared to other radiations because charge number and mass number are decreased much greater than the other radiations. Okay, now the second radiation is beta emission. Beta emission. uh, Remember, beta emissions, beta means the electron of the nucleus. This is the electron of nucleus actually because it has negative charge. Beta has negative charge. There are three types of beta. Original beta is negative charge, anti-beta is positive charge, and there is a neutral beta which is neutral. Okay, so remember, beta is a very lighter particle. So the process of beta emission will have no change in the mass. It does, however, change the atomic number. Means there is some sort of charge on the beta particle which is equal to the charge on electron or proton. So beta emit will change the atomic number, means the charge number, but will have no effect on the mass number. Okay, so remember, if beta negative emit means original beta emit, so the charge number will be get increases by 1, and if the beta positive is emitted, beta positive mean anti beta is emitted, so the charge number will be decreased by 1. So beta emission has no effect on the mass number, but it affects the charge number. So beta negative increases the charge by 1 and beta positive decreases the charge by 1. Okay, look at the example. We have a parent nucleus X which has X ZA which emits a beta negative. So its charge number will be increased by 1 and there is no effect on the mass, and anti-neutrino will be emitted plus Q1. Okay, anti-neutrino will be emitted. This anti-neutrino will be emitted for the sake of love condition of charge, for the love condition of momentum, for the love condition of energy, for the love condition of mass. So if we ignore this neutrino, so all the natural laws will be violated. So this neutrino is a very high penetrating small particle. So this is placed by the scientist neutrino for the sake of love condition of mass, love condition of momentum, love condition of energy, love condition of charge. So if there is a negative beta emitted, so there will be anti-neutrino will be emitted. If the beta positive is emitted, there will be neutrino negative emitted. Okay, look at the example. If we have a parent nucleus X, it emit a beta positive, so its charge number will be decreased by 1, means Z minus 1, and there will be neutrino is emitted. So look at the neutrino. Neutrino is negative charge. For the beta positive, there will be neutrino is emitted for the sake of love condition of charge, momentum, energy, and mass. Okay, look at the specific example. Suppose we have a thorium. We have a thorium 90 and 234. Okay, so it emit beta negative. Beta negative mean electron. Okay, electron is emitted, so it will convert it into pallium 91. Pallium has a mass of 91 and charge of 91, and there will be anti-neutrinos emitted plus Q1. Anti-neutrino means positive charge, because if the electron is emitted, there will be positive charge. So look at here, the charge number is increased by 1 and the mass number is remaining same. So beta emissions increase and decrease the charge number while it has no effect on the mass number. Let us take another example of neutron. So look at the neutron. Neutron emitted an electron. Neutron emitted an electron, so it becomes proton with anti-neutrino. So let us take an example of carbon. Look at carbon 14. So it emitted electron, so it becomes nitrogen 14 plus anti-neutrino. Okay, let us take an example of carbon 11. Carbon 11 emit a positron. A positron mean anti-beta. Anti-beta, so it becomes boron B5. Okay, plus neutrino. So these are the example of beta emission. Okay, now the third one and the last one is gamma emission. Gamma emission, what is gamma? Gamma is actually a photon. Gamma is actually an energy. It is not a particle, discrete particle. It is not a concrete, a solid particle. It is actually an energy. Um, Most frequently, the alpha and beta emission leaves the daughter nucleus in an excited state. Such nucleus may go back to a more stable configuration, eventually to its ground state by emitting one more gamma ray. Gamma rays are massless photons. Their emission will cause no change in the mass, no change in the Z. Z means the charge number. So gamma is the energy. It has no charge, no mass. So it means it will not affect the charge number and the mass number. Actually, when alpha emitted from a heavy nucleus, beta emitted from the heavy nucleus, so the nucleus will have some excitation energy, means the nucleus will be still unstable unless if it emit a gamma emission. So if it emit a gamma emission, so it will get it will get a complete stability. So look at here. The question is where this gamma emission comes from, where this energy comes from. So the answer is, look at here, we have proton, neutron inside the nucleus. So, and these proton and neutrons are very close to each other, so they will share their mass with one another. Means there will be some mass defect with one another. So they will share some mass with one another and there will be mass defect, and that mass defect will be converted into binding energy. So the proton and neutron will have some binding energy, and if the nucleus is unstable and that binding energy released from that nucleus, so that binding energy is called the gamma emission. So gamma emission is actually the energy, the photon. Okay, look at the reaction. The reaction is, suppose we have parent nucleus X, it emitted a gamma radiation, so it will remain X. There will be no change in the mass number and in the charge number, but this nucleus will be more stable as compared to this nucleus. Okay, so this is all about the gamma emission, alpha, beta and gamma emission in the radioactive decay process. If you have any queries, you can WhatsApp and or you can comments on this video. Inshallah, I'll reply. Okay, take care. Allah Hafiz.